And now I'm going to continue exploring this eyes on exoplanets. And I guess this time I might as well give some commentary on how I'm going about my exploration. So let's begin. It's nice to first start by going and just picking some random star that's out there in the galaxy. And it seems to be right now, most of the exoplanets that are both pending to be confirmed and actually confirmed are in the Milky Way, because those are the congregation of stars that are closest to us. So let's go ahead and find some star that's near us. This looks promising. HD 26965. 16 light years from Earth. That's not bad. And it shows here, this is the habitable zone. This is the place where the temperature would be right for possible life. Unfortunately for this star though, it seems that its only exoplanet seems to be outside of this habitable zone. And strangely enough, this is a K-type star, which is going to be less bright as the sun, because the order of the stars are O being the brightest, bluest stars, then B, A, F, G, K, M. And this is a K-type star, which means it's one of the lower mass stars and not as bright. However, we can see these are still close to this star. And as it seems to be, the habitable zone does have this lower limit, even though it's not going to have a very high temperature, probably because of the winds from the star. It would still be uninhabitable. A Neptune-like icy giant planet. How could this be icy when it's so close of the inside of the habitable zone? Inside the orbit. Wouldn't it be too hot? How could it be icy? Well, I guess at the same time, even comets are icy when they are near the sun, even though they do sublimate. So that's maybe gives a hint on how it could be icy even though it's inside of the habitable zone. I think this is still interesting. If we had Voyager space probe, it would take 290,000 years to reach this place. And how is this exoplanet detected? Radial velocity. It measures slight changes in a star's velocity as the star and the planet move about their common center of mass. Wow, this is actually one of the more difficult ways to discover an exoplanet, especially because of the atmosphere and how disturbances from the atmosphere may cause it to seem like there was a change in the radial velocity. They still confirm this to be an exoplanet. Now let's move on to a different exoplanet. How about we go ahead and look at one of the missions and see the Kepler discoveries. For now, since there are so many that seem to be here, let's first look at the confirmed ones. Great. And now we could even filter it further, it seems, by planet type. Let's first look at the Neptune-like planets. And now, why not? Let's just choose something interesting. Two planets orbiting a K-type star, 91 light years from Earth. Okay, let's see. They're inside the habitable zone. Let's see. What does this look like? Nice. Okay. And now, why don't we just compare this system to our regular solar system? Oh, wow, everything's pretty close. All of these planets are inside Mercury, or inside the orbit of Mercury. But this is a K-type star. However, because of the solar winds and the ejecta coming from the star, it would probably not be possible to live here. That's probably why this zone of habitability ends at this point. Wow, look at this. If Earth were able to orbit this star, it would be in the habitable zone. Wow. They really did a good job at creating nice graphics, even though we don't know what the star looks like. They still gave this nice fluidy motion to the star. Let's go back to a different star now. How about now we go to the browse planets? These are the most visited planets and the most famous ones. And this one was the one discovered by the James Webb Space Telescope. Not discovered, but they were able to get a very good spectrum by looking at this star using this telescope. So, let's look at the description. Very nice. Distinct signature of water, along with evidence for clouds and haze in the atmosphere of this hot, puffy gas planet. So they probably did choose this planet since it is kind of in the habitable zone and would be able to harbor life. Is it not? I guess not. It's not within the habitable zone of the planet. So they probably had other reasons to choose this planet. But it does seem to have water in its atmosphere and have clouds. Oh, but it's a gas giant. So it's probably very interesting, even though it's not Earth-like. So many observatories are seeing exoplanets. Let's see. Subaru telescope. What can it tell us? These are the planets observed by the Subaru telescope. Let's go to a blue star and see what it finds. Where is the star? A-type star, so it's a pretty blue star. Second only to O. And the zone of habitability is here. Let's see, compare this to our solar system. And you have to be as far as Saturn in order to be able to survive close to the star. If you were where Earth was to this star, then it would be way too hot considering this is an A-type star. So, this star is actually farther away from the habitable zone. So, you can't really have life on this star as we know it. But, let's go on to it anyway. Oh, pretty. A gas giant. Very good. And now, to end it, let's just go back home. Thanks for watching.